case, for example, so the spectra of signal xt is shown in the following figure. Spectra. So you have a DC when the frequency is 0, DC. Okay, right here omega is 0. And then you have a complex value when omega is plus minus 15, a negative frequency is 1.5 e to the minus j pi over 5. A positive frequency, it's a 1.5 e to the minus j pi over 5. Okay, so that is one set right here. This is one set that can result in a cosine. Okay, then there's another set of frequency right here when omega is plus 45 and then omega is minus 45. So you can form another cosine term out of this. So what is displayed here is the cosine. Cosine in complex exponential form. Cosine omega t, you know, right, from the Euler, is 1/2 e to the j omega t plus 1/2 e to the minus j omega t. You guys know this. You guys know this. This is the thing that's being displayed here, and it's called spectra. So now you're given the spectra, you're going to find these things. You're given the spectra. You're given the spectra right here. This is spectra. Let me take the pointer. So these are the spectra of DC, and then there's a AC here, and there's another AC for this pair. And then you go into write an expression in complex exponential form, or just in exponential form. This is 3 DC plus, first you look at this part here. Maybe I will just highlight this part. So write an equation for this as in the form of complex exponential form. So will I write an equation for that? It's going to be 1.5 e j pi over 5. Okay. The amplitude and phase. The amplitude is and phase. So you have one amplitude and phase. This is amplitude and phase right here. And that is occurring at what frequency? A frequency that is minus 15 pi. Correct? So you're going to put e to the minus j 15 pi t. And then you're going to do the same thing for the other part. On the positive side, you have the complex exponential, the amplitude and phase is 1.5 e to the minus j pi 1.5 times e to the minus j pi over 5 multiplied by e to the minus j, sorry, e to the positive j. So happening on the positive side of the frequency, j 15 pi t. Okay, then plus So you do the same thing for the other pair. Let me circle this right here. Writing a similar equation for this is going to give you 3e minus j pi over 3. It's happening at minus 45 pi. J minus 45 pi t. Make sure you include a t when you write in exponential form. And then plus. On the positive side of the frequency, you're going to get 3e j pi over 3. The positive frequency e to the j 45t. So this part here is like the amplitude and phase, like this part is here.
Sir,
Yes?
for the exponential J45, right? The pi must not include us, sir.
Yeah, the pi should be there. Thanks. Somehow it slipped. Very good question. Gideon, keep it up.
So that wasn't me, so that's Kavin, sir.
Arun, sir, Arun.
Arun, sir.
Very good observation, Arun. You're getting, you're beginning to become a good guy, good boy. Good. All right. Okay, let's move on. Now let me rewrite these things. You have a DC here, and then plus. Now I'm going to look at this part here first. Look at that part. So what I'm going to do, I'm just going to factor out the 1.5. Factor out the 1.5 and then just multiply the exponents. Sorry, multiply the exponential functions. When you multiply them, the exponent will add up. The power will add up, right? So that's going to give you, but usually remember we write like this, omega t, or plus or minus theta, right? Usually that's the form we write. Let's go ahead and write the way it is right now. So I'm going to write this part here, j pi over 5. I'm going to write the frequency part first. Between pi t. Okay, I'm going to put the j outside and then I'm going to call this minus 15 pi t plus pi over 5. Okay, for this part, I'm just combining these two. As the way it is, I'm not factorizing anything, I'm not changing the sign. I'm just leaving it minus 15 pi here. I'm just going to leave it there. And this pi over 5, I'm writing the frequency times time first. And then the phase part. That's a norm. That's how we usually normally write things. We write the frequency, remember, for example, e to the j omega t plus or minus theta, right? In that format. For the other part, e j, same thing again. I'm going to just leave. This is 15 pi t minus pi over 5. Okay, close the parentheses. Close the parentheses. Next, I'm going to combine these things together. Plus 3, factor out the 3. Then you write the frequency part. You put the j outside. And then you write minus 45 pi t minus pi over 3. And then plus e to the j 45 pi 45 pi t, so pi over 5 of pi over pi over 3, right? 45 pi t minus pi over 3, so plus pi over 3. So you guys have any questions so far?
No, sir.
Make sure you guys understand these things because these are very important questions. They will show up in the final. So let me continue processing this. Okay. 3 plus 1.5. So I'm going to look at this right now. This part here. E to the j. So okay, I'm going to look at this one first. So let me look at this part first. So that's going to be just e to the 15 pi t minus pi over 5. Let's next look at this part here. So that's going to be E J. I'm going to put minus sign outside here so that the frequency, the term inside becomes positive, minus pi t. And then that's going to give you minus 5t plus 15. That's going to give you, wait, minus pi over 5. Okay. So like minus j 15 pi is still minus j 15 pi t. So j multiplied by pi over 5. I put a minus sign here. Minus and minus becomes plus. It's still maintaining the same sign and the values. So let me do the reason for doing this. We want to put this in a standard format like this. Okay. Usually we have the minus sign outside and the plus sign outside in standard complex exponential form so that we can convert that to sinusoid using the Euler's formula. If you do the same thing for the other part, So you're going to get 3 E. So if I factor out this, if I factor out the minus sign from here, so let me bring this over, do this part first. I'm doing this part first. So there's no change on that. J 45 pi t plus pi over 3 plus e to the, then I'm doing the other one. This part here. You pull out the negative sign. So you have to be very careful in this because make sure you don't do any mistakes in the algebra. So like you can see this part here, get this part here, right here, and this part here. You just factor out the minus sign. You factor out the minus sign, it comes outside, and then minus J45T, still minus J45T, minus J multiplied by pi over 3, still minus J pi over 3. Once you put them in this format, once you have them in this format, then you can go ahead and, this part here is same as 3 multiplied by, why don't I just writing these things, okay, never mind. It's just going to be 3 over E minus EJ. So it's going to be just same as, just like multiplying by 2 on the numerator, and you divide by 2 in the denominator. Okay, similarly here, if you multiply by 2 and then divide by 2, okay, you can just delete this and I'm going to show you this, but don't too much writing. Multiply by 2 and then divide by 2. So therefore this becomes 3, 1.5 times 2 becomes 3. And then this whole thing here. So this whole thing is cosine 15 pi t minus pi over 5. In order for you to do that, you have to ensure that it's in the proper format. Inside here, both of them should be the same. Only the sign outside here is different and should be divided by 2. Then you can write this as cosine 15 pi t minus pi over 5. The same for the other one. Three times 2 is 6. 3 times 2 is 6. And then that will be cosine 45 pi t plus pi over 3. So this is the expression that we want. This is 2 pi T1 is 2 over 15, rational number, 2 over 45, a rational number, rational. So they are periodic. So if T1 over T2 is 2 over 15, divided by divided by 2 over 45, which is same as 45 over 2. Two and 2 cancels, 45 over 15 is 3. So period is, we cross multiply this, so it's going to give you T1 is 3T2. So your period is T1 or is 3T2, same thing. It's 2 or 15 seconds. Understand the question. A signal ST, a signal XT is given by this equation here. This cosine 250 pi t minus pi over 6. And its spectrum as the form. This is a spectrum. This is a DC. Omega is 0. Here, they're giving you not the omega, but F. F is hertz. Omega is radians per second. They're giving you the frequency, the cyclical frequency, F1 and minus F2, positive frequency, amplitude X1, negative frequency, amplitude X minus 1. Please note this minus 1 is associated with the negative frequency. Okay, this plus 1 is associated with the positive frequency. That's why this is called negative and this is positive. Please keep in your mind that determine the values for F1, X0, X1, X minus 1. Or the frequencies are given in hertz. So the first thing you want to do, this is really convenient since they already given you the equation. So you can go ahead and write this equation in exponential form. Please take your piece of paper and pencil and try to write this in complex exponential form. Please spend a few minutes trying to do this. Okay, now you write this in complex, write the cosine in complex exponential form. Okay, this is how you write it. Complex exponential form. So the whole thing must be considered as theta, the whole thing. We can consider the whole thing as theta. It's like a cosine theta. Cosine theta is e to the j theta, 1 half g to the j theta plus 1 half e to the minus j theta.
So far, so good, sir. No question.
Okay, that's a very long reply. How about the other guys?
No, sir.
No questions, sir.
Okay, sir.
Peace, sir. Peace, sir. So now you multiply the 3 through. So you will get 3 over 2. Okay. And let's multiply that out first. E to the j 250 pi t. That's a frequency part. And the other part is the phase part. Ej to the power of minus e to the power of minus j pi over 6. So this is the frequency part. So you get that very clear here. This is the frequency part. This is the amplitude and phase. In this case, some of them may just don't have phase. We just have an amplitude. Okay. So in this case, the amplitude. Okay, let me rewrite this. This for now. Just let me combine this first. Then I will label them. Plus 3 over 2 e minus j 250 pi t multiplied by e to the minus j pi over 6. Once you have it, so now what you need to do, okay, well, you need to note that this is the frequency part. Okay, like this part here, it's a frequency. Similarly, this is the frequency part. So the phase part, the phase and amplitude part is this. This is the phase and amplitude part. Amplitude and phase. This is the phase, amplitude and phase that we call the coefficients. Right? We call these coefficients. So we combine the amplitude and phase together, it will give you 3/2 e to the minus j. Okay. Then you put the frequency part separately. Similarly, on the other side, you multiply the amplitude with the phase part. Frequency part, and the other, separate. So it's easier for you to see the coefficients. So like this part is the coefficient. And that is, so this coefficient is associated with a positive frequency. This is a positive frequency. Positive frequency. Okay, the amplitude and phase that is associated with a positive frequency is x1. So this is the negative frequency. It's negative because of this negative sign, okay? That's why I call negative frequency. I'm calling it negative frequency. I don't know about other guys. Of course, you know there's a negative frequency, which is expressed in the exponential, the exponent. So from there you will understand that's related to negative frequency. So the coefficient and amplitude, or the amplitude and the phase associated with the negative frequency is x minus 1. So now, having figured that out, you should be able to answer your question, isn't it? Okay, now the question is asking you this, and to answer this. So this is the question. You're supposed to know these things. F1, F1, X0, X1, X minus 1. F1 is quite easy to find. F1 is, you already know, F1 is 2 pi, sorry, omega over 2 pi, right? Omega is, so this is the omega. This part here is the omega, right here. Omega. You know, there are no two omegas here. There's only one omega here. You don't have to see here, you have to come here and see. From here you can see clearly there's only one omega here. In the past, people have, because there's only one omega here. There's only one frequency. Just because you separate them into exponential form, you're going to have two omega. People were calculating two different periods for this. But there's no two period. There's one frequency and there's one period. The cyclical frequency is the radians per second, 2 pi, 250 pi divided by 2 pi is going to give you 125 hertz. Make sure whatever you do, you give me the unit. What about the DC? DC equals to what? DC. A DC? What is a DC? Jivinder, what is a DC value? Jivinder,
Yes, sir.
what is a DC value? X0 is the DC, right? So what is DC? Kavin, what's the DC? Kavin,
Yes, sir.
what's the DC value? Feng Sheng Wei, what is the DC value?
Is it the 3/2?
3/2. Luckily, you're not in the class, you know. Never mind. Okay, how about Yanla?
Is it 0, sir?
Very good. DC is 0. Guys, you cannot see the DC. There's no DC, right? You can see there's only AC here. Is there a DC here? DC, there's no these things is an AC because it depends on the frequency. In DC, there's no frequency. You see, DC will stand out by itself without any dependency on the frequency. That's a DC. Do you see anything like this in that equation? If you guys are electrical engineers, you've taken circuits 1, circuits 2, sorry, the circuit 1, and then you still don't know what is DC and AC. In this equation, if I go and plot this, it's clearly showing you the frequency is 250 pi, the amplitude. So if you just plot this, you're going to get a sinusoid. Okay, with the amplitude of 3. Where's the DC here? If you have a DC, then you will see there's a DC offset. So this is the DC, but there's no DC. You can see from the equation. It's really very sad, you know. I don't know why. Am I not doing a good job or what? This is all coming from circuits, electrical circuits class. Who is still confused about this? That the DC is 0? How come Yanler knows this? Okay, do you guys agree with this? Agreeable answer? Is anyone still confused? Why DC is 0?
Understand, sir.
Right here, this is the DC and omega is 0. G, what did you say?
I say I understand, sir.
Understand. Omega is 0. This is the DC. But there's no DC in the equation. In the equation here, there's no DC. No DC here. So DC is 0. Then what about X1? X1 is equals to what? G?
3/2, sir.
Are you sure G?
Yes, sir.
Who's thinking okay.
3/2 E negative J omega over 6.
Say that again, E to the J. Repeat that.
Okay. 3/2 E negative J pi over 6.
Just now you say omega, right?
Speed up.
Okay. Then what about So x1 minus x minus 1. Given, what is x minus 1? Given.
Yes, sir. Yes, sir. Yes, sir. Is it x if the negative 3 or 2, sir?
Kavin,
Sir, 3/2 EJ 5/6.
right? Okay, now you look at the signal here and you tell me what is the DC value?
1.
Okay, who said that?
Lankesh, sir.
Oh, thank you, Lankesh. Do you guys see why the DC is 1? Who cannot see? This is a DC and this is AC with an amplitude 3 and the frequency 300 pi. And this is also AC with an amplitude 2 and 500 pi frequency. This doesn't have, there's no phase shift. This is an AC, amplitude 3, frequency 300 pi, but there's no phase shift. On this one is also an AC, amplitude 2, frequency 500 pi. There's a frequency shift. Sorry, there's a phase shift. Okay, periodic signal is given. Find the Fourier series coefficients. The same as before. There's coefficients like you found here, right? Previously, earlier on you were given this spectrum. From there you wrote the equation. Okay, and the second one, yes, sorry. So you were given a spectrum. You wrote the complex exponential form of equations like this, and then you combine the phase and amplitude, and then you separate the frequency part, and then from there, that's how you figure out the Fourier coefficients, like this one. So like this one, right? Fourier means something related to frequency. Okay, now we'll go ahead and find the Fourier series coefficients for this. So what you guys going to do? You're going to, first thing what you will do to find the Fourier series coefficients. What did we do to find the Fourier series coefficients? We broke up the sinusoidal equation into its exponential form. See, one thing, if you note this equation, so I would like to tell you that xt is 1, that's a DC. There's some things I'm missing here. Let's see, the 0 cosine 200 pi t. But then you have, I mean, the component at the frequency 200 pi is missing. Then you have a component at 300 pi. But then you are missing the component at 400 pi. Maybe this is not really exam, but I'm just trying to give you an idea what these things mean. So you have no component at 400 pi, and then but you have a component at 500 pi. 2 sine 500 pi t minus pi over 4. So this is what you can say, like you can write this equation as for this case, this part here. And then by right, you're also missing, let me rewrite this, push a little bit here. So you're also missing the component at 100 pi. Okay, this is like equivalently saying that when n equals to 1, you know, let me write this in a red color. So the frequency component can be written as n 100. The frequency is like omega. You can say omegas of n is 100 and pi. Okay, so you're going to get like n equals to 1, 2, 3, and 4, and 5, and 6, and so forth. Okay, so n equals to 1, it'll give you the Fourier coefficient of A1, A2, A3, A4, and so on. When n equals to 1, then omega 1 is, when n equals to 1, omega 1 is going to be 100 pi, right? 100 pi, there's no component. When n equals to 2, omega 2 is 200 pi, or there's no component. Therefore, there's no coefficient. When n equals to 3, it's going to be 300 pi. We have here, no problem. We have an amplitude, and definitely that means we're going to have Fourier coefficients. When n equals to 4, then you're going to get 400 pi for frequency, but there's no components there. So there's no Fourier coefficients. When n equals to 5, then we have 500 pi t. So that we have amplitude, and then therefore we're going to have Fourier coefficients. So in this equation, the whole story is not told. So I'm just telling you what this means. Only the odd frequencies is appearing here. But except when n equals to 1, 1 is also odd. But the odd frequencies are appearing here. Only in 3 and 5. When n equal to 3, you get 300 pi. When n equals to 5, you get 500 pi. So DC, and you have a component, and you have a frequency, and you have a AC at 300 pi frequency, and then you have another AC at 500 pi frequency. So at 300 pi frequency, the Fourier coefficient is going to be A3, right? Because when 300 pi, that relates to n equal to 3. So the subscript 3, when n equal to 3, subscript is 3. Fourier coefficients A5 relates to n equal to 5. So the Fourier coefficient that you're going to be dealing here is only, you don't have this, we don't have this, we don't have this. It's going to be A3 and A5 only. Any question on this? When we do the problem, you'll see what I'm talking about. But for now, do you understand what I was talking about?
Yes, sir. Clear.
You don't simply say whatever you like, G, and to make me happy. Later on, I want to see that in your work. How about the other guys? Arun, Jessica,
Yes, sir. Okay, sir.
Yes, sir.
Bernard, Tan,
Yes, sir.
Go Sang Deng,
Yes, sir.
JJ,
Yes, sir.
surely, sure. For DGC, we just leave it. So write the exponential form of the equation for 3 cosine 300 pi t becomes 3 e 300 pi j 300 pi t So that is representing cosine 3 cosine 300 pi t. The 3 is outside here. Cosine 300 pi is this. So next one, we will do it for this part here. Plus 200, plus 2 multiplied by e to the j minus pi over 4 plus e to the minus j So in this case, since there's no place to write, I'm going to put them right here. Okay, is this correct? So next, 1 plus 302, and then 302 e to the j 300 pi t plus 3/2 e to the minus j 300 pi t. Okay, that's for this signal here. That's for this part here. Okay, for this part now, we're going to do the same thing, but in this case, we have phase also. So we have to take care of that too. But 2 divided by 2 is going to cancel. So therefore, e to the 500, e to the j 500 I'm just writing the frequency part, and then the phase part is e to the minus j pi over 4. The phase part, e to the inside is e to the j pi over 4. A naught. So x, what should be the subscript here? Sorry, A. What should be the subscript? Come here and see what should be the subscript here. When n equal to 3, when n is equal to 3, you're going to get what? 300 pi, right?
N equals to 300 pi.
So the subscript should be A3, isn't it?
Yes, sir.
Yes.
Because we are not going to be putting here A300 pi. We want to see when we write the Fourier coefficient, we go like n equals to 1, 2, and 3, and so on. As I said, mentioned earlier, from the Fourier, when we do the Fourier series integral, right, usually we have n dependency of the frequency. Anyway, so this is going to be A3 because it's associated with the positive side of the frequency, and this part here is associated with the negative side of the frequency, so it's going to be A minus 3. So this one here is associated with the positive side of the frequency, so it's going to be A5. This is going to be associated with the positive side of the negative side of the frequency, so it's going to be A minus 5. Any question on this? No question, then I continue. So therefore I can go ahead and write A naught is equals to 1. A3 is also my A minus 3. It's going to be 3 over 2. If it's just a simple amplitude without phase, so usually the coefficient will be the same. A3 and A minus 3. So what about A5? A5, if you look, A5 is e to the minus j pi over 4. And A minus 5 is e to the j pi over 4. Right? So you can, so usually you will say A5 is the conjugate of A minus 5. Conjugate. Conjugate means we make the imaginary part. We change sign on the imaginary part. Okay. So that's how you guys do it.